Ia. Bună ziua, 2, 2, 10, 10, probă, e bine. 2, 2, 2, 10, 10, probă.
Transgaz, a responsible company, a company of the future.
Șprițul, o băutură cu tradiție, merită mai mult. Din dragoste pentru șprițul perfect, alege un vin bun, muzica lăutărească autentică și noua Aqua Carpatica cu bule puternice, dar catifelate. Aqua Carpatica Carbo la doză de 0,30.
Good afternoon. Welcome everyone. This is the New Generation Warfare, New Technologies, Unmanned Systems in the Black Sea Region, Deterrence and Defense Perspective panel. So it should be a very interesting and exciting and evolving topic. The basic concept of this panel is to discuss the lessons learned so far following the Russian invasion of Ukraine in terms of technology and use of unmanned systems, as we've observed there. How can unmanned systems contribute to NATO defense posture in the Black Sea region? What is the cost-benefit ratio for the use of unmanned systems and anti-unmanned air vehicle devices? And then finally, I think it's worth thinking a bit about what missions are in fact the most suitable for the use of unmanned and what is the right mix that's appropriate. So we've got 5 panelists here. I'll introduce them each first, and then we'll give them each about 10 minutes, and then we look forward to your questions at that point. I'm planning on sitting here, but any of you who like, when your time comes, you feel welcome to go up to the panel if you like. So just going in the order in the program, let me go down the list here. First, we're lucky to have Lieutenant General Viorel here. Started his military career in 1989 as a fighter pilot, and later he became an airlift and instructor pilot. He has over 31,000 flying hours logged as an airlift pilot and has participated in more than 200 missions in the theater of operations in Iraq, Afghanistan, Bosnia, and Kosovo, and has conducted many humanitarian missions both in country and abroad, including Libya, Montenegro, Chile, China, and Mali. He commanded the 90th Airlift Base, and since 2017, he's been the Chief of the Romanian Air Force. And thank you very much for being here, sir. Next, Rear Admiral Mihai PANAIT is the Chief of Naval Forces Romania. He began his career in 1991 working in the minesweeper operations, followed by tours as operations officer, and then commanded a mine warfare ship, and then in several leadership positions in the mine countermeasure squadron community. As a flag officer, he was the Chief of Staff of the Fleet, Chief of Operations and Training, and then the Fleet Commander. And on July 2020, he became the Chief for Romanian Naval Forces. I'm looking forward to your comments, sir. Then we have Rear Admiral Iuri, I'm sorry, I'm going to slaughter your name, COVALEOV, the Deputy Chief of Military Intelligence for Intelligence, Surveillance, and Reconnaissance. He started his military career as the Chief of Communications on board a fast patrol boat squadron, followed by positions as a combat unit commander. Later, he was Chief of the Public Relations Department as spokesperson for the Navy staff. He's completed his Master's in Military Science Intelligence and his PhD in Military Science. He has served as a military air and Navy attaché in Russia and Ukraine, and since then he has served as the Strategic Human Director and as of August 2020 as the Deputy Chief of Intelligence for ISR. Very interesting career, sir, and glad to have you on the panel. Immediately on my right is Mr. Craig BORCHELT. He's a Senior Manager of Autonomous Systems at Boeing. Boeing Autonomous Aviation and Technology with Boeing Autonomous System, and responsible for managing all new business campaigns involving autonomous aviation defense programs. Craig graduated from the United States Military Academy at West Point with a degree in international relations and has both a master's in business administration and a doctor of law degrees. In past Boeing efforts, he supported the Army Future Combat Systems Program, the KC-46 tanker, and all rotorcraft platforms offered by Boeing. And we look forward to your insight from industry. And at the far end, we have the pleasure to have Navy Captain, retired Oren from Israel. He was commanding officer and served in the fast boat community, which I found interesting, and worked in that arena. At the more senior level, he was the head of weapons systems in the platforms branch at Navy headquarters, planning department. As a captain, naval captain, he became the commander of the Red Sea Arena project, focused on the ISIS challenges. And at Iliad Naval Base, he then became the head of the SAR-6 vessel and the EEZ protection project, mostly trying to help Israel control the situations across the Eastern Med, and there are many oil rigs and other facilities in that region. He concluded his naval career as a senior instructor at the Israel National Defense College, and since then he has worked at IAI Naval Program and EEZ protection in both business development and marketing. So thank you very much for being here. So with that, I'd like to, as I said, go in order of the program and ask Lieutenant General PANÄ to offer his comments, and ask you each to do about 10 minutes or so. Thank you.
Thank you very much for your kind introduction. Ladies, gentlemen, generals, admirals, officers, dear participants, I would like to thank our host firstly for the kind invitation, and I will also like to stress that I'm really honored to be present here today to debate on this topic, unmanned systems in the Black Sea region. I will shortly detail on the following topics: new generation warfare and how this impacted the latest conflicts, including the Russian invasion in Ukraine; new technologies, which have added a gray component to the regular conflict patterns, a component barely visible but highly effective. I will then focus our debate on the unmanned systems, and particularly how were these weapons used in this just 400 kilometers away conflict. And last but not least, I will try to conclude by offering some ideas on deterrence and defense in the Black Sea region with respect to those measures and unmanned systems. Some will argue that warfare is a confrontation between economies, some other between strategies or tactics, and all are right. I'm just looking at it as a confrontation between ideas and means at hand. As technology evolved and advanced, the ability to obtain effects by combined actions from land, air, and naval assets has become the essence, firstly, of mechanized war, and later on maneuver warfare. Nowadays, the space and cyber domains have been added and act complementary with the air domain in order to obtain effects across multiple domains of operations. New generation warfare requires ISR, strike and recovery capabilities that enable joint effects and in which the air domain play a major role. Based on the tenets of air power, speed, reach and height, and the additional ones, ubiquity, agility and concentration, automation, machine learning, robotization and artificial intelligence have been introduced and added value to air operations. Moreover, the positioning of surveillance systems in outer space led to unprecedented level of knowledge, bringing a decisive advantage and winning the dominant position in the war. And this is not just about the opponent, but also about own forces as well. Add that to the synergy between military and civilian technologies and domains, as today's activity is proving. This phenomenon was confirmed in the framework of the Russian-Ukrainian conflict, in which Ukraine was supported by civil companies to obtain data and information about the movements of Russian troops. UAS systems employment in recent conflicts, including the most recent one, the Russian aggression against Ukraine, stand as testimony that UAS will represent a bedrock of conducting military actions. Will be that the most proeminent is yet to be seen. Ukraine is one of the first major conflicts where drones have played such a high-profile role. But the race in high-tech weaponry that could be used in conflicts began in Iraq and Afghanistan war, where MQ-9, Reaper, and some loitering drones started to make a difference on the battlefield. I want to highlight the big difference between the uncontested air superiority in the Middle East conflicts and the hostile environment contested air superiority in Ukraine. In this conflict, both sides have deployed lots of lethal drones against each other. Some sophisticated, but others adapted to just drop grenades on enemy troops. Ukrainian drones targeted Russian forces during the first months of the war, and enormous convoys and ships were hit and forced to immediately adapt to this kind of war. That made both sides aware of the effects, costs and limitations of this new technology and the necessity to adapt. The conflict is also introducing lethal autonomous weapons on the battlefield, and as a consequence, Ukrainians use loitering munitions like Switchblade 300, which can loiter for around 15 minutes, and it's designed to take out small targets, and Switchblade 600, which can loiter for around 40 minutes and take out armored vehicles. All of these can be controlled from as far as 40 kilometers. Drones have given Ukrainian forces the ability to fuel cheap and persistent air power despite the limitations or the limited capability to employ conventional air power assets, and this strategy brought significant threat to Russian ground forces. Regardless of the conflict evolution, we assess that Russian systems will continue to represent a major threat in the Black Sea region. Alongside the desired effects in the Ukraine war, where played a predominant land support role, Russia will continue to employ both manned and unmanned systems in order to deny access and limit freedom of movement in the Black Sea. Now, as deterrence can be looked as a three-legged stool of capability, capacity, and willingness, Alliance activated its defense plans, significantly increased the number of forces, and deployed elements of NATO response force on eastern flank, enhanced the level of training through national and multinational exercise as an essential requirement to maintain the readiness level. And NATO will continue to employ Allied air power, including unmanned systems, such as the Alliance ground surveillance assets, in order to obtain vital indicators and warnings. Air and missile defense systems are able to detect all of these, are able to engage most unmanned aerial systems. But the cost-benefit ratio, if such systems will engage a low-cost swarm of UAS, is totally not efficient. A possible solution would be to employ short-range air defense and anti-aircraft artillery. In the same time, progress is needed in adapting laws and regulations. In this respect, I want to emphasize that Romania has taken important steps in ensuring legal basis to fight against drones on the national territory, at least. One of these steps was realized with the promulgation of the changes to the laws regarding the regime of weapons and ammunition owned by the Ministry of National Defense. Also, the war in Ukraine continues to push the boundaries of the rules of engagement. The next phase in new technologies warfare is promising to change these rules of engagement. I believe that it's mandatory to regulate what happens when artificial intelligence is to make its own decisions, or who is friend or foe, whether to proceed to engage on, and what are the ways to undo such a control in case technology fails. But I do also believe that we should not see this artificial intelligence as the silver bullet or as a solution for everything. Now, unfortunately, we have to solve all these problems already facing the two of the four horsemen of the apocalypse. And I'm speaking here about the COVID-19 and about the war in Ukraine itself. Nevertheless, we'll have to adapt. The traditional DIME model, diplomatic, international, informational, military, and economic, reminds us that military power does not sit away from the other instruments of power, and sadly, the war on the European continent proves to be, for the men and women in military uniform, a harsh wake-up call that the threats to our democratic way of life have not gone away. To conclude, when speaking about the future capabilities, we should think of air and space superiority, ISR, rapid mobility, strike and command and control. All of the above mentioned could, and I believe that they are greatly impacted by the use of unmanned systems, and this weaponry, with more and more advanced features, could be a differentiator to help us shape a new architecture designed for the deterrence and for defense posture, and could be touted as the future of air combat vehicles. Thank you.
Thank you very much, General. Thank you very much. Hello? Okay, there we go. Thank you very much, General. Appreciate your comments, and very interesting. If we can now go to Admiral PANAIT from the Chief of the Navy, please.
Thank you very much, Greg. Good morning to everybody. I am Rear Admiral PANAIT, Chief of the Romanian Naval Forces. First of all, I would like to congratulate our hosts for the success in organizing the 7th edition of the Black Sea and Balkan Security Forum 2022. And because outside we have a little wind, I would like to wish for our partners fair winds and following seas for this edition and for the next two. I have a presentation in order to support my intervention. Today I will present to you some considerations related to unmanned systems, the use of it into Ukraine-Russia conflict and the challenges they bring into our specific current and future activities. The agenda of presentation is depicted on the screen. Next, please. Okay. Over the last decade, unmanned systems have become regular presence into conflicts. The use of drones, unmanned aerial systems in particular, illustrates the huge potential of unmanned systems. Unmanned vehicles are indispensable for various applications where human intervention is impossible, risky or costly. At this time, missions of unmanned systems are diversified for each combat environment and are listed on the slide. The concept of an unmanned system certainly provides enormous advantages. For example, the most common roles UAVs fulfill are ISR, command and control, C2, combat and combat support, targets indicator, target practice. On screen there is a SWOT analysis regarding the unmanned system and their impact on using in military domain. From operational point of view, from the strategical to the tactical level, military experts conclude that autonomous weapons systems not only confer significant strategic and tactical advantages in the battleground, but also that they are preferable on moral grounds instead of use of human combatants. The combat actions on the territory of Ukraine show us how the unmanned system used are part of modern warfare. In this case, drones have different missions from recognize and surveillance to missile attacks and against enemy missiles or armored vehicles. Initially, at the beginning of the conflict, Ukraine possessed a small number of mostly Soviet-made drones, withdrawn from combat service and reintroduced with the start of hostilities in the Donbas region. These systems take their name from their mode of action. They are launched without a specific target, perform a service area in the air until assigned a target by the ground operator and then actually engage the target. The Russian military industry has been present at military exhibitions during the last 10 years and this presence has been reflected and supported in or by media. Of interest were various autonomous unmanned systems designed to be used in all combat environments with missions starting from ISR to combat missions. The most important equipment presented are those displayed on the slide. Information from open sources indicate that Russia has used during the conflict just a few unmanned vehicles from its inventory. Regarding the use of these systems, existing data and information leads us to the following conclusions. The most used unmanned system were the aerial ones. Their role in the conflict was not decisive. The missions of the equipment used being specific to support actions, mainly for ISR missions, targeting and battle damage assessments. In the medium term, the use of the unmanned systems will experience an exponential growth, both in terms of quality and quantity. We believe that use of autonomous maritime systems marks a paradigm shift regarding the ethical nature of warfare at sea, generating debates regarding the design and especially the operation of these systems, all seen through the lens of the United Nations Convention on the Law of the Sea and the Law of War. In the next decade, we believe that unmanned systems will be more present on the battlefield in all combat environments with extending tasks assigned. Unmanned systems designed to conduct combat action in joint environments may emerge. In close connection with the development and implementation of other concepts, such as artificial intelligence, cloud, machine learning, unmanned systems will gain more autonomy in decision-making. Next step, unmanned and autonomous weapons systems will expand the battlefield, allowing combat to reach into areas that were previously inaccessible. Unmanned weapon system can reduce casualties by removing human or fighters from dangerous missions. From this perspective, and take into account ethical bound, we consider that is one more aspect that must be emphasized, moral justification. The Romanian Naval Forces are carefully following the offers of the military defense industry in order to equip it with unmanned system, especially for unmanned surface and underwater vehicles, for mine warfare and unmanned aerial vehicles for ISR missions. Regarding the development of the new generation of unmanned system for mine warfare, Romanian Naval Forces is part of the European Union project, Maritime Semi-Autonomous for Mine Countermeasures, MAS-MCM, or is part European Union Networking Diving Centers too, in order to endows the Navy with new capabilities. Concerning the ISR missions, we are looking for tactical unmanned vehicles class 2 and USV small boats. And for example, I would like to underline the Romanian Navy effort in the last 6 months in order to keep the freedom of navigation in our area of responsibility, in the Black Sea area, speaking about the mine threats. It's a lot of work in order to keep the routes, to keep the freedom of navigation in this area, and we are involved in this operation with a lot of ships, a lot of vehicles, a lot of forces. And I want to underline the most important role for unmanned system, because we had involved in this operation the Eurocopter from the Romanian Coast Guard, from the European Union, and with this kind of equipments we succeed in our mission in order to keep the freedom of navigation in a very good shape. We have more examples, speaking about the gliders or sonobuoys or EMATs, speaking about the anti-submarine warfare domain. ladies and gentlemen, I hope that my presentation contributes to a better understanding of unmanned system and most importantly to understand the challenges that these new technologies and military equipment pose both to society as a whole, to the military industry and to the military personnel. Thank you for your attention, and I am ready to answer to the questions. Thank you very much.
Thank you very much, Admiral. Next, if we can go to Admiral COVALEOV, please. Interesting to hear the more specific ISR's perspective.
Okay, ladies and gentlemen, good afternoon. New Strategy Center, thank you very much for the invitation. I'm sure that new generation warfare and technologies will be an important topic for debate from now on. I have approached the topic from the intelligence superiority perspective, emphasizing the importance of deterrence and defense in the context of new generation warfare and technologies in the Black Sea region. The security situation in the Black Sea region evolved from a volatile one to an open conflict in the vicinity of NATO borders. The Black Sea region is mostly exposed to Russia's military position and its assertiveness in the area. Russia is the dominant state actor in the Black Sea region, aiming to maintain control over the near, abroad, and to undermine NATO's efforts in the region. At the same time, Ukraine, the Republic of Moldova and Georgia are still perceived by the Kremlin leaders as a buffer zone between Russia and NATO. It's obvious that Russia has already demonstrated its willingness to use military force in order to protect its interests. The invasion of Ukraine, illegal annexation of Crimea, as well as the presence of Russian troops on the territory of Georgia and Republic of Moldova significantly demeaned regional security. The Russian invasion in Ukraine prompted significant consequences on the national and regional security environment. A future possible advance of Russian forces towards Romanian eastern border and the occupation of Snakes Island will increase the military threat to Romania. The increasing flow of refugees will put additional pressure on the economic and social care systems of Romania, Republic of Moldova and Poland. From the economical perspective, Romania and the EU will face short-term challenges as a result of reducing the dependency on Russian resources. The security situation in the Black Sea region remains volatile and could further demean, as this conflict has already consequences that are echoed beyond the borders of Ukraine. Now, moving to the core of the topic. In our view, aggressive ISR operations represents the ability of the ISR capabilities to perform persistent joint missions as part of NATO indicators and warning capabilities. All information needed to have an intelligence superiority could be stored in a secure cloud capability. The access is granted on the need-to-know principle, and information is used for fulfilling the objectives depicted on the slide. The picture that you can see is not necessarily a cyclic process. All the stuff can be used for operational purposes in a variety of combinations. The cooperation between NATO European states and NATO partners could be the core of the deterrence and defense operations in the Black Sea and lead to a common operational picture and a common reaction in terms of maritime domain awareness. And Admiral PANAIT has pointed out some of these issues in his presentation. The unmanned systems could be a possible solution for a smart approach regarding deterrence and defense of the Black Sea region, and this approach is focused on three pillars as showed on the slide. The first one is the development of new surveillance and reconnaissance capabilities focused on unmanned systems. The relevance and use of unmanned systems are constantly rising in a variety of ISR missions. At the same time, they offer a live stream, real-time video, and image capture, targeting information along with the ability to carry striking capabilities. But the main advantage is the security provided to the operating personnel, which is located far from the area of operations, and the risk to be affected by the enemy's action is lower than ever. The second pillar is related to the integration of these capabilities. The volume of data and information collected require advanced tools for processing. Big data mining for maritime situational awareness is needed for indicators and warnings on certain patterns of life, historical comparison, etc. The use of artificial intelligence for various applications in maritime systems is being explored and is used for collection, databases sharing, but also for command and control process. Secure cloud storing will be helping the decision makers to have access to the information needed for understanding the operational environment, the intelligence common picture, and to access the target information folders. All the factors will conduct to an intelligence superiority in terms of deterrence and defense of the region. The cooperation between the Black Sea riparian states for implementing the first two could be mentioned as the third pillar of our approach. In our view, a possible strategy for deterrence and defense of the Black Sea could be based on multinational integrated maritime situational awareness, based on the contribution of the riparian states of the Black Sea and the common reaction having the same goal. Moving forward from the static ISR coverage that we have nowadays and building a new mobile, autonomous, integrated and interoperable ISR will lead NATO to the intelligence superiority. In order to use all surveillance and reconnaissance capabilities at full potential, we will need strong and reliable emergent technologies such as artificial intelligence, big data, and cloud computing. Intelligence superiority is based on the maximum usage of all platforms for ISR processes. The continued proliferation of the unmanned air systems provided increased opportunities for both military and non-military actors to leverage their capabilities in planning and executing attacks against military and civilian objectives. The technological advance has made them, especially the first class UAS, widely accessible, increasingly sophisticated with better capabilities in terms of sensor speed, performance, payload, range, and endurance. UAS threat scenarios include but are not limited to those presented on the slide. There is no single counter-UAS technological solution that is effective against any threat at any time and place, but rather it depends on scenario, environment, and general situation of the objective to protect. The generic processing chain for countering UAS include detection, tracking, identification, and mitigation of the threat, while the second and third class unmanned air systems could be countered by air and missile defense capabilities. The first class pose challenges to existing integrated AMD due to their low kinetic profile, reduced radar cross section, and ease of proliferation. As mentioned earlier, the type of counter-UAS solutions should be chosen according to the objective to protect. It could cost from thousands to millions of euros, from the most simple ones to complex. As an example, the drone attack that disrupted Gatwick Airport for 3 days in December 2019, affected 1,400 passengers, 1,000 flights, and cost over £50 million. The counter-UAS solutions deployed later at the airport cost around £4 million. The next generation of ISR systems will be able to transmit combat-relevant data to all the other components of the combat system, land, air, or navy, using processing, exploitation, and dissemination capabilities. Interoperability and sensors integration and cooperation will be the key enabler for achieving information superiority and the effectiveness of targeting process. Manned-unmanned team is likely to be a successful operation due to the opportunity to minimize the human exposure to many dangerous situations which may occur. Intelligence architecture represents a very important tool to achieve the main goals in terms of deterrence and defense of the Black Sea region. An open architecture will be scalable and integrated in a node of network. All platforms will communicate to each other and will create a dynamic mode for the entire network. Military command will have many questions related to the best way to complete their missions in the Black Sea region, and they will be facing many challenges. Another challenge is to decide the use of artificial intelligence, the ability to assess the situation within a second and offer a possible scenario or a possible response. This could help the military decision process, but it cannot replace it. And Lieutenant General PANÃ has touched this point as well. Finally, we assess that all ISR capabilities, manned and unmanned systems, the cooperation between the Black Sea riparian states, and the common understanding of the Black Sea region and NATO objectives in the area will get the intelligence superiority that will support command and control and will generate a common deterrence and defense reaction. Thank you very much.
Thank you very much, Admiral. Maybe we should get a drone to go up and tell that dogfight going off in the sky to quiet down a little bit. Okay, next we have Mr. BORCHELT, please, from Boeing.
Good afternoon. My name is Craig BORCHELT. I'm from Boeing, and on behalf of Boeing, I'd like to say how pleased we are to be a main sponsor for this event. Thank you all for attending, and thank my fellow panelists for what's been a great presentation today so far. When we talk about autonomous systems, if we went around the room today and asked each of you what your definition of autonomy is, I think we'd get a different answer from a lot of different people. It's really difficult when you get into this space to get a common definition of autonomy. I'm going to talk for a minute about the future and what we see at Boeing and some of our developments for the future. And as I do that, I want to talk for just a minute about that definition of autonomy. We typically talk about autonomy. I think it's a generally accepted definition that we look at autonomy on a scale from 0 to 5, 5 being full autonomy, 0 being about no autonomy. And I'll talk today about a loyal wingman type aircraft that has an autonomy target of about 4, which is not total autonomy, but more control or more autonomy than most systems. So let's have a kind of a common definition there. But I do think as we talk in this unmanned autonomous system segment, it's important to have kind of a common definition of what we're talking about. As we go forward, we have a tremendous evolution in the way we're going to fight on the battlefield, as I think we've talked about already. And as we look towards these loyal wingman systems, and I'm going to use that as an example going forward, really what I would call, for lack of a better term, an unmanned fighter. One of the things that we're developing at Boeing, the MQ-28 in Australia being an example, also called the Air Power Teaming Systems, shows the capability that's being brought to bear right now and will be available in the not-too-distant future for commanders on the battlefield. The MQ-28 is a loyal wingman aircraft. You can team up to 4 of those aircraft with a manned aircraft. Now think about that for just a minute. You'll typically see that talked about in terms of teaming an unmanned fighter, it's called a fighter a lot of times, with a fighter. But it doesn't have to be just teamed with a fighter. It can be teamed with any type of manned aircraft. So the ability to team a loyal wingman fighter-like aircraft with a KC-46 tanker for protection, with an E-7, with a P-8. A lot of different aircraft types that aircraft could be used with an Apache helicopter. An Apache helicopter right now, with its existing configuration, an AH-64E, can team with an MQ-28 with no change to that Apache helicopter. Think of the combat capability that an Apache helicopter pilot would have in a combat scenario to need additional assistance and be able to have an E-7 task, a loyal wingman aircraft, to that Apache helicopter pilot. And then that Apache helicopter can then task that loyal wingman aircraft, that MQ-28, to prosecute a target of opportunity going forward with no additional equipment needed in that Apache helicopter. A loyal wingman aircraft right now that we've designed is intended to be about 10% of the cost of a manned fighter. 10% of the cost. That has real implications in terms of your ability to purchase that kind of an aircraft, and also teaming 4 for every manned aircraft has real implications for mass. So as you talk about defense budgets, which are always constrained, you talk about the need for mass on the battlefield, the ability to bring that type of mass at much lower cost can really have a revolutionary impact on military force structure. It's really something, if you think about it, that's going to have an impact. Now, if you look at what Australia is doing right now, and they've been very open about the fact that their MQ-28 has been in production. It's in production now. It's been in flight testing since February of 2021. So here's an aircraft that's now moving its way out eventually to the force structure. These systems are out there now. This isn't a picture. It's not notional. More than one aircraft's been in production. I would say that in the not too distant future, as flight testing progresses at some point in the future, as you get into more air shows in the future, as we get the air show circuit fully back operational post-COVID, you'll start to see a few of them at an air show. You'll be able to go up and touch them. We've had customers now come and see them and actually touch them and say, wow, we thought it was just a picture, but you guys actually have them. They're coming off the production line. It's a really important thing to understand. They're being manufactured now. That's a really important thing for the battlefield as well. Think about a commander's mindset today if he or she knows that going forward for a high-value target, they can have an unmanned system that they can lose. They can go after that target and be willing to lose that system because it only costs a few $1 million. How aggressive they may be able to be going after that target versus how aggressive they might be now using a manned system. We get a lot of questions when we talk about the MQ-28 about, we understand it's valuable, we kind of understand what it would do, but we really don't understand the CONOPS. We really don't understand how we would use it in the existing force structure. I think that resonates with a lot of folks today. What are the real CONOPS? How do I fit that into the force structure? Our force structures are designed not really to incorporate unmanned systems, and the unmanned systems that we're incorporating today are more ISR loiter systems that we use to augment our existing force structure, where when you look at a loyal wingman system, you're really talking about incorporating it into the force structure completely. If you're talking about putting 4 for every manned asset into, let's say, a fighter squadron, that's a significant addition to the squadron. It's not an augmentation. Now you're talking about a complete force structure change. So it does cause you to rethink, how do I do maintenance? How do I do command and control? How do I do those different things? Those CONOPS haven't been completely figured out yet. I won't tell you that they have. We're working through that. We're doing a lot of modeling to fully understand the implications of that. I will tell you that the modeling that's been done to date, and there's been a lot, shows a very interesting and compelling impact to capability on the battlefield. And for the cost that and the capability, the cost versus capability that comes to the battlefield, I can assure you that these systems are going to be employed by our adversaries going forward in the future. So it's really, really, I think, compelling to look at the Loyal Wingman type aircraft and understand with those autonomous capabilities, Loyal Wingman being one example, but I think it's really an important one because that pointed nose fighter-like aircraft that augments the current force structure, the capability that it brings at a low cost, high value point in the force, really brings a compelling value proposition to militaries today. And as you look at that, it's also going to be a very compelling value proposition to everyone's adversaries as well, to all militaries across the globe. So if you're not on board with adapting that capability, I think you need to understand that most likely if you're going against someone in the future, they probably will be. So usually that is a great thought-provoking discussion. I'm going to leave it at that, and as we get to question and answers, I'm sure that we'll have some more discussion on Loyal Wingman capabilities. Thank you very much.
Thank you very much, Craig. Next we have Captain Guter, and I'm looking forward to his presentation in particular because you can give us maybe some examples from a different environment being involved in the Mediterranean and the Red Sea.
Good afternoon, everybody. After 30 years of service in the Israel Navy, I joined IIIb, the Israeli Aerospace Industries, which is the largest defense company in Israel, supporting the Israel Defense Forces for many years regarding the operational challenges that we are facing. And being humble, I was listening to the leaders of the armed forces of Romania here, and I've heard that we are sharing quite same challenges regarding unmanned systems here in this region, in the Eastern Mediterranean and in the borders of Israel. We have a global presence regarding unmanned systems all over the world. The leading system were unmanned air systems. Early in the 70s, we have faced Eastern doctrines of air defense that prevented our aircraft to operate openly and freely in all domains. And we have we've been the pioneers for unmanned aerial vehicles, using them in all perspectives. Also for ISR missions, intelligence, but taking that capabilities for other domains like USVs, loitering munitions, unmanned underwater vehicles, mainly because when you are facing air defense system or coastal defense of missiles, and you still want to maintain your superiority and your capability, using unmanned vehicles gives you more operational flexibility to enter that area. And we have a term, stand off and stand in. All the time, the tension between those operational perspectives of trying sometimes to do stand-off missions, and sometimes you have to be stand-in. And for that, we have all that variety of UAVs, from small tacticals vertical takeoff and land, tactical male and male plus, and the difference and the variety is immense, because starting from local and aerial missions up to standoff, long-range missions, and combining that, I want to speak a bit about the challenges of the battlefield as we see it. First of all, we have high mobility targets. We need to be able to operate day, night, all weather. We can say that our opponents are also learning and studying the capability of UAVs and unmanned system. So they are lowering their signature, they are shortening their exposure, they are minimizing their emission, and they are using more and more from very short up to long-range air defense systems. So standoff missions are becoming a main requirement nowadays. Also, we have time-sensitive time targeting generation, because of your enemy is suddenly popping up, launching rockets, and suddenly again hiding in his areas. You need a fast and accurate decision-making processes. You need an actionable intelligence in context, and that I'll show with our system how we do it. And you need a continuous situational awareness in the area. When you take all of that, we understand that the solution actually is a combination of a platform and a sensor suit. Okay? If you are talking about a tactical UAV or tactical systems, mainly they can carry only optical sensors, very minimal capabilities. And on the other hand, if you are using a big, real big UAV, they are more vulnerable to air defense systems. So we found in the middle the proper solution, which will on one hand be able to carry all those sensors, and I'm speaking about radar, maritime patrol radar. I'll elaborate a little bit in a few seconds, or synthetic aperture radar capabilities, moving targets, sensors, L-int, COM-int, etc. So it comes in one package. So if I take all those payloads overview, I say a very accurate EOIR with target recognition capabilities, signal intelligence, which will be a layer for COM-int and signal intelligence as part of the identification of the hostile activity, radar, wide area motion imagery, and as the leaders here spoke about artificial intelligence and machine learning capabilities as part of the understanding of the area. If I may, for my Admiral colleagues here, I want to elaborate a little bit about our maritime patrol radar, which is a unique system that our maritime UAVs and is carrying. It has a coherent radar, which enables you actually not only to find a target, but also regarding the different frequencies that the radar is radiating. It enables you actually to get the figure of the target and we have a bank of targets for enable us to classify a target and to get actually in the end in a very long range the capability to classify immense amount of target in an area, and we do it also in land targets with our synthetic aperture capabilities. Here you can see the distances very, very long at sea of our identification. So actually, our mission is to take from all of the sensors the immense amount of data. You know, technology is an opportunity, but it's also a challenge, because nowadays we are facing a huge amount of data that we have to be able to calculate and to understand. So we have to take the data, process it into information, and then into intelligence that will enable us to have a proper decision how to act, how to allocate our resources, etc. And we are doing that with, and I just took an example yesterday night from the systems that are tracking targets in the Black Sea. But you can, these are only the emitting AIS targets. In the area, you can find hundreds of other fishermen boats and other boats that are not regulated to transmit accordingly. And we are actually facing the same challenge in the Eastern Mediterranean. We have a crowded maritime and air arena, constant threat across maritime borders, superpowers presence in the area, a large scale of transfer via sea, and regional arm race. And what actually we are doing, taking all that information from all the sensor, we are doing data association, taking signal intelligence, radar, electro-optics, everything as analyzing the target. Our software is learning, our software, our command and control system is learning the patterns in the area for long time. It's not only a day by day, we are learning the patterns of targets sailing from one place to another. And if there is a target is changing its course suddenly, or suddenly a target is popping in an area which is not relevant, it becomes an anomaly, and the system signaling us that there is a suspicious area. We are also taking all that information together with the synthetic aperture radar information, and we are finding the targets that are not emitting. We now understand that they are more suspicious. So all of that together is giving us, on one hand, a platform, a sensor suite, and the brain, the command and control that gives you a clear maritime and area situation awareness. So just to conclude, our family of systems led by the Heron UAS, multi-intelligence is highly capable, multi-sensor, long-endurance UAS, transferring vast amount of data into an actionable intelligence. Most of the processes are automated and supported by AI battlefield proven tools, and it's in the end it shortened the process from a sensor to effector. Thank you very much.
Thank you very much, Captain. So we've heard a series of excellent presentations summarizing the use of unmanned and autonomous systems, air and maritime applications in intelligence, surveillance, and reconnaissance, some real-world examples using the loyal wingman to supplement manned missions, looked at a range of ways you can think about the payload options from the Israeli approach, as well as an assessment of their situational awareness. So we have about 10 minutes now, and I'd like to invite the audience then to have questions. Otherwise, I'll ask my personal questions, but I think it would be better if you jumped in. Hans, please. General Dahman.
Thank you very much, Greg. I'm a child of the 60s, so I grew up with Star Trek in the 70s. There is a great episode called Touch of Armageddon, where Captain Kirk goes to a planet where there's no more fighting. They just have two computers that every month they have a round of computer fighting, and then afterwards the computer decide how many people have to be cremated. And I've got the feeling, if I hear the foreign talking, that we're moving in that direction. Technological solutions, everything. But both the Chief of the Navy and the Air Force alluded to the change we need in command and control systems. And what I see, what I believe to see in Ukraine, is more decision making, faster decision making at a lower level. So aren't we looking at Mission Command 2.0, where we give more responsibility and more means to the lowest commanders in order to fight the fight? And then what does that mean for centralized control?
One of the chiefs like to take that?
Thank you very much for your intervention, for your question. From my point of view, it's very important to adapt C2, command and control, for the future. We have to build another C2 in order to be available and to be ready, speaking about the readiness to fight in this new battlefield. It's very important to invest in the understanding for the future, to invest in our officers and PT officers in order to exploit this new generation system. Is very important from my point of view. And the concept, the difference between theory and practice to be in everyday this difference is to be shortened, and it's very important to train to experimentation and another experimentation every day. In other words, it's very important from my point of view to reduce the understanding of the fog of the war. It's very important. Thank you very much for.
Well, there is you are perfectly right, sir. How low you would delegate the command and control? Like yourself in the 70s, in the 90s, I was learning about mission command. I would say that these new technologies, the UASs, are really making possible this concept of mission command. And the reason right now that the situation is as it is, as you describe it, in Ukrainian conflict, is that the Russians are not able to execute mission command and are trying to micromanage the command and control from the higher levels, and that's the reason that they are losing they lost so many generals in the first phases of the war. As far the Ukrainians are commanding with the lieutenants and with the NCOs the same tactical operations. But again, this was made possible by these new technologies. The extent that we are going to adapt our concepts of operations and tactics to having these new technologies will give us the measure of our success in the future.
Thank you very much. Another question?
All right. I have one question to Craig about the wingman concept. What type of, you said you're gonna like reduce the cost like 10%. So where do you sacrifice the capabilities so that the current systems cannot accomplish? So you must be reducing some of the things to reduce the price.
That is a great question. First, I would point out that about up to 60 to 65% of a manned aircraft's cost comes from accommodating the human factors in the aircraft, everything from the ejection seat to the oxygen to the avionics to allow the pilot to function the aircraft. So we do get cost savings there. Secondly, to keep the aircraft attritable, we've done things to make it, it's for example, the fuselage is not robust enough to last 6,000 flight hours. It's considered an attritable aircraft, so we may not reinforce the fuselage as much as we would for an aircraft that we expect to last 6,000 hours. There are certain things we've done. The MQ-28 does not go over Mach 1. It's a sub-Mach 1 aircraft. We save money there by not reinforcing the fuselage to go over Mach 1. And I would just add that, that is, as with anything, as you bring an aircraft like this to market, customers want it to do all things. And we have been very rigorous at that cost point, because as you look at mission, if you all of a sudden make your loyal wingman aircraft cost $20 million, it completely changes how you look at its employment. So you have to be really rigorous at keeping the cost down. And as we get mission creep and we have customers who say, I really wanted to do this and I really wanted to do that, our response is we can do all of those things, but there's going to be a cost. And do you really want your attritable loyal wingman aircraft to cost this much? And that usually causes the discussion to pull back from those, what we would call exquisite requirements, back to the baseline requirements to do the baseline missions, because cost is critical in keeping this CONOPS, this employment of low cost attritable. Attrition is really the key thing. We're willing to lose it to protect the pilot. We're willing to send these things out, and potentially we don't necessarily want to lose them because we don't want to lose the payloads, but we are willing to lose them.
Other questions from the floor? We have time for at least one more. Otherwise, I get to ask it. I was going to ask this for you, Captain. I was looking at all the different options you had up there in terms of size, capability, cost, survivability, expendability. What is your experience in dealing with the military customer base on how do they make those trade-offs and trying to decide what they want to buy? I mean, you looked at the whole scale, and you have quite a few options there. So what really is the process they go to for your end-use customers to decide, okay, I guess that's really where I want to be, vice there, and you have all those factors, capability and cost. What goes through their minds, and how do you work with them to make that sort of decision?
III has an operational team of retired officers like me that are coming to the country and studying and learning the challenges and the missions and the geopolitical environment on one hand, and on the other hand, taking the experience of the process in Israel of how we are trying to actually calculate the proper solution, because it's, in the end of the day, it's what we call the battle economy. Everything is you're trying, because every time budget is limited, and defense is the art of optimizing actually defense versus economy. So we are trying to take a proper solution, and I just showed an example. On one hand, there are tactical small UAVs that are needed in the area, and high altitude as well. but we understood also in the Israel Navy when we are looking at the challenges in the Eastern Mediterranean and also in other domains that Heron UAV is the optimized solution when you understand that it's not only the UAV, it's also the sensor suit and the abilities of communication, because if you want to be able to operate, you need a satellite communication, then it's another payload. So in the end of the day, mainly for mission of ISR and intelligence missions, especially if you want freedom of navigation, etc. It's a matter of trying to optimize a solution, and I think humbly that we found a proper one that was presented here to the audience.
Thank you very much. I think our time has reached an end, unless somebody is desperate to get a last question in, or one on the panel wants to make a final comment. Seeing none, then, I want to thank the New Strategy Center for letting us have this opportunity to discuss unmanned systems and autonomy. Very interesting topic. Thank you to both Chief of the Navy and Air Force for being here, along with our naval expert on ISR, and also both from Boeing and IAI experts to be here to talk about their systems. And I hope they'll linger a few minutes if you have a few questions that you did want to ask and from the full crew. So I'll bring the panel to a close here, and thank you very much.